Hello and welcome to our lab on electrostatics. Today we'll be talking about the charge that it can be on different materials. Now these charges can be either a positive charge or a negative charge. Now what that means is, for a negatively charged object, that object has an excess of electrons. Electrons carry a negative charge. For a positively charged object in our lab setting, that object is going to have a lack of electrons. Again, electrons carry a negative charge, so if you have a lack of electrons, your object will have a net positive charge. Now, online there is a list of materials called the triboelectric series. Triboelectric means the electricity generated by rubbing two objects together. And so pick any of those two materials on the list, rub them together, and their order on the list tells you their relative charge. If one is higher on the list than the other, it will charge positively. If the one is, and the one that's lower on the list will charge negatively. This means that the one that's higher on the list gives some of its electrons to the one that is lower on the list. And then their separation, if they're very close together, there won't be a very large charge difference between them. But if there is a lot of separation between the two on the list, then there can be a large separation. So their position of the list not only tells you which one is going to be positive, which one will be negative, but it also tells you sort of relatively how large of a charge difference they'll attain. Now, for example, we have some Scotch tape. We can take one piece of tape, pull off another piece of tape, and then I'm going to just assume that the sticky part is a different type of material than the non-sticky part, so I'll put those two parts together, sort of like this. And then when I pull them apart, I find that they attract to one another. This attraction is due to the fact that they now have different charges. One's positive and one is more negative. So charges that have different charges will attract, but charges that have, objects that have like charges will repel each other. Now, even though I know that these have different charges, that one is positive, one is negative, I can't yet tell which is which, or how much charge it is. What I have to do is look at it with a charge sensor. Now we have these vernier charge sensors here, and let me sort of describe this apparatus to you. This is a charge detection apparatus. I'll break it down a little bit here. First of all, I'll start with a grounding plate. Now this plate is neutral, no net positive or negative charge. One way I can assure that is to touch my hand on it and then touch my hand to something grounded, say the metal on the back of the computer. And that sort of neutralizes this grounding plate. Now on top of that, I have this electrically insulating pad and an electrically conducting metal ring here. When I place that down, charge is not transferred from the ring to the grounding plate, but I can join them electrically with this wire. So now if my grounding plate is neutral, and I neutralize it by touching the back of the computer at the same time as I touch the plate, that also means that now this shield, this mesh, circular mesh, is also neutral. Now here I have a cup, and this metal cup is the cup I'm going to use to test the charge of different objects. And so my charge sensor that reads the charge difference, I'm going to attach the red lead to the cup inside here, and it's insulated from everything else. And the black lead I'll clip to this shield, which is electrically neutral. And so now if there's a negative charge in the cup, this will read a negative charge in Logger Pro. If there's a positive charge on the cup, then this will read a positive charge in Logger Pro. So by using this apparatus, I could then put one of my pieces of tape in there and determine whether it's negative, if I just hold it in there, or positive. Now here on the table I have several different materials, and these materials are represented in your triboelectric series that you have online. I have cotton cloth, wool cloth, and vinyl or PVC material. Now these three different materials, I can rub these on either these two wands or these two discs, and I'll generate a charge. Represented here is a nylon disc and a nylon wand, and also a PVC disc and a PVC wand. But I'm not going to tell you which is which. You'll have to experimentally determine that using your triboelectric series. I will tell you though that when you rub the cloth with one of these discs, be very careful. The threaded screw in here breaks out easily, and then we have to send it to a machinist to retap and rethread. So be very careful with the apparatus. Rub gently. Now, to test the charge, you'll predict a charge based on the triboelectric series, positive or negative. To detect that, you will take your charge sensor, zero it using this zero or null button on the right hand side, and then as you dip this into the cup, the charge sensor will read the charge. You don't need to touch the cup at all. You just dip it into the center of the cup and read the charge off of the screen. When you remove it from the cup, the charge should go back to zero. And so by this you can make predictions on what charges are and try to determine what sort of material this is made of. Now there are two major ways that you can charge something. We're going to charge this cup itself. We didn't touch the cup before because we didn't want to charge the cup, but now we're going to charge it. And there's two ways we can do it. First of all, we can do it solely by conduction. So if I charge this, and I'm not going to tell you whether this is positive or negative, but let's say it's negative, a 50-50 chance. If I touch the cup, the side of the cup, I'm going to transfer some of the charge from this wand into the cup. And if this was negatively charged, then now the cup should be negatively charged. And as I look at the with the charge sensor reading, it should retain that charge even after I pull this away, because I've made a physical contact and I've charged the cup. Now it's charged. Now another way to charge is by using a combination of conduction and induction. And let me sort of give you an example of how that works. I'll zero out my charge sensor again so that the cup again reads a neutral charge. And then this time when I charge, and I don't know that it is, this might be negative or positive, let's say it's negative. When I bring this to the cup, I'm not going to touch the sides of the cup this time. I want to do this without touching the cup. By touching the cup, I'm going to give the cup the exact same charge as this had. If this was a positive charge, the cup will be positive. If this has a negative charge, the cup will be negative after I leave. But I want to charge the cup oppositely. Here's what I'm going to do. So let's say if this has a negative charge. I put it down in here because like charges repel, there's going to be pressure on the electrons that are in the cup itself. And so when I attach this wire from the neutral shield to the cup itself, this gives a path for electrons to move away from the wand. So they've moved away from the wand, through the wire, and into the outer shell, this outer shield. And so now when I remove the wire, the electrons have no way of getting back in. So now I take the wand away. I never did touch the cup with the wand. And because those electrons have no way of making it back into the cup, this is what's happened. The cup has lost electrons due to my little path here that is no longer available, and now the cup is positively charged. This means that by that combination of touching the cup with the wire and holding the cup there, inducing a charge, I was able to charge the cup oppositely of what the wand itself was charged. Last of all, there are a few tabletop demonstrations that we'll be performing, or you will be performing. First of all, we have a steady stream of water coming out of a can by the sink. And as it turns out, when you charge one of the wands and hold it close to the stream of water, try not to get it wet because moisture can kind of kill the electrostatic effect, but it will deflect the stream of water. Now, as it turns out, when you charge a wand the opposite charge, you still get the deflection in the same direction, and you're asked to explain that. Similarly, if I have this can on the table and I charge a wand and I hold it up to the can, there is an electrostatic attraction to the can, but that attraction is still in the same direction no matter if you use a positively charged wand or a negatively charged wand. The can never repels. And so you're also asked to explain that using the principles you've already learned in the lab about electrostatic attraction and induction.